Okay, so let's review this first attempt that we made at the Unit 3 test. Provided you have taken all of your formative assignments, you may retake this test Thursday after the PSAT testing, and I will provide a link. But before we do that, let's try to review. We'll go over these questions just to make sure that you don't miss the same things twice. So here's our reference table that had the polyatomic ions in it. This isn't necessarily in the same order that you took the test, but they are all the same questions. What's the name of this substance? Well, it's got more than two elements in it, so it's not a binary compound. It must be one of those ones that has a polyatomic ion in it. This is one that you guys did fairly well on, and recognizing that that first combination of those two elements is one of the polyatomic ions called ammonium. That right there is fluorine, but when we put it into a compound like this, we change the name to fluoride. We put the IDE in the end of it. So that's ammonium fluoride. Now, the name of this formula, we see that first element there is manganese. That there is chlorine. So this is chloride. But manganese is one of these elements that's in the D block that has the Roman numerals needed in the name of their compounds because they can sometimes have a charge of 2, 3, 5, even 7 for manganese. Well, what was the charge number for manganese here? It must have been 2 with the drop in cross. So that is manganese 2 chloride. What is the name of this substance? Well, we've got copper. Well, the first element being copper. Another case where we've got more than two elements. So we must have a polyatomic ion. That right there, if you look up from your chart, is the sulfite ion. It's sulfite, not sulfate, because it's SO3 and not SO4. But remember, copper is probably one of our more common elements that we use here from the D block that has more than one choice for its oxidation number. So copper can have a couple choices. What was its charge number here? Well, sulfite from my chart, I know is a -2. Well, that means copper must have been the +2 version because when they crossed and dropped, they got eliminated. So this is copper 2 sulfite. What is the formula for disulfur pentachloride? Disulfur, di would be 2, S2. Penta refers to the number 5. That prefix means there's 5 of the chlorines. So disulfur pentachloride would be S2P5. Now, as it turns out, there was a typo in this particular version of the test, and you see that's not one of the choices. So this question wasn't even scored for you. What's the name of this substance? Well, we've got here in parentheses one of these polyatomic ions. We see there's 2 of that polyatomic ion in this compound. The element here in the front is cobalt. That polyatomic ion is the cyanide ion. Cobalt is one of those ones that has a couple different choices for its oxidation number. I know cyanide's a -1 from the chart. That means in this case, this must have been cobalt that gave 2. So it's cobalt 2 chloride. Boron monofluoride. Now, boron is the letter B. Sorry, monoxide. Boron monoxide. Well, oxygen is letter O. No. Mono means there's only one oxygen. there must only be one boron, otherwise it would have a prefix of di, tri, tetra. It would have some prefix to tell you that there is more than one. So the correct formula for boron monoxide is just BO. The name of this substance. We've got two elements that are both over here on this side of the periodic table. They're sharing electrons. It's not a metal, non-metal. It's two non-metals. So when these guys get together and share electrons, we have to use those prefixes to name them. This is sulfur. And that's oxygen, so it's oxide, but there are three of them, so I have to say trioxide. How many sulfurs? Well, there's only one. I don't have to say monosulfur trioxide. I just say sulfur trioxide. Now, some of you on the test called that thing sulfite. There is a polyatomic ion that is SO3. Remember, polyatomic ions are things that are charged. The sulfite polyatomic ion would be SO3 expressed with a -2 charge. This would be SO3 with 2 extra electrons, and that would give me a polyatomic ion. There's no charge on this. This is a compound. The name of that compound is sulfur trioxide. The name of this substance, well, it's another case where we've got phosphorus over here and we've got bromine over here. We've got two non-metals on this side of the stair step that are sharing electrons. We have to use the prefixes. Well, the first thing is phosphorus. How many are there? There are 3. We've got to say triphosphorus. The bromide for bromine, how many? There are 7. The prefix for 7 is hepta. So this is triphosphorus heptabromide. I'm not going to actually do the math on these because I don't want to take the time on the video to actually punch the numbers, but I will show you the setup of this. You have 0.252 moles of NaH. I want to know how many grams that is. 1 mole of NaH is 24 grams of NaH because sodium's 23, hydrogen is 1. Together, the mass would be 24 grams of NaH in 1 mole. The name of this substance, here we got our friend copper again. And we've got sulfur just by itself, so it's going to be sulfide. But at this point, we should recognize, hey, copper is one of those ones that needs a Roman numeral. Oh, which one is it? Well, if we know sulfur was a -2, in order for them to be reduced, it must mean copper must have been the +2 copper in this compound. The name of this substance, oh, here we got copper again. So we've got copper, and now I should really recognize that copper has to have one of those Roman numerals. Well, this thing over here is the sulfate ion. This charge, this number there must have come from the copper, so this would be copper 3 sulfate. The name of this substance, it's carbon and oxygen, 2 nonmetals sharing electrons. We've got to use those prefixes. If the first element only has 1, we don't have to say monocarbon, we just say carbon. For the second element, we have to say the prefix with the name of the element. This is carbon monoxide. Now, drawing the Lewis structure for water. Lewis structure is when we show how the electrons are being shared. Well, here's hydrogen with its single electron. We know oxygen has 6. And they get together and they're going to share some electrons. They share those 2 and they share those 2. So now if we look at oxygen, it has 2, 4, 6, 8 electrons by sharing. And that's good. That makes oxygen happy, satisfies the octet rule. But the question is, how many lone pair of electrons? A lone pair is a pair of electrons that's not being shared. In other words, it's a pair of electrons with one atom not between two. And we see here for oxygen has 2 pairs that it has by itself. So there are 2 lone pairs of electrons here. Okay, mass of silver nitrate to give you 2.5 moles. 2.5 moles of silver nitrate. 1 mole of silver nitrate is some number of grams of silver nitrate. The question is, where do I get the number of grams? I got to go to the periodic table. Silver is about 108. So silver's 108 plus 14 for nitrogen plus 48 for oxygen, because there's 16 for each oxygen, but there's 3 of them. So we got 48, 14, and 108. So what would that be? 112, 122, be 170 grams. And you do the math, get the answer. What's the formula for iron 3 phosphate? Well, this is iron that's giving 3. Phosphate is a polyatomic ion with a PO4 that has a -3. So I cross and drop, but they're going to cancel each other out. They're going to reduce. So that's the formula. And in this case, that was actually on there twice. Didn't matter which one you picked, it would correctly give you credit. What is the name of this substance? Well, this is zinc. This thing here is the hydroxide ion. Now, you might think that zinc, being in the middle of the periodic table, needs one of those Roman numerals, but zinc is one in the middle that doesn't need a Roman numeral. Zinc always has a charge number of 2. So I don't need to use a Roman numeral for zinc, because zinc is always 2. I don't need to say zinc 2 hydroxide, because it's always 2. What's the name of this substance? So this is a compound that must be 2 elements sharing electrons, because they're both nonmetals. Most of you got this one. It's 1 nitrogen, 2 oxygens, dioxide. Name of this substance. I've got carbon. Just have one of them, so I don't have to say monocarbon. I just say carbon. And I say tetrachloride, because there are 4 chlorines that are sharing electrons. The formula for titanium 2 oxide. Notice this guy's got a Roman numeral. That means its charge number is 2. Oxygen is always a -2. So when we cross and drop, we just get TiO, because those 2 reduce. That right there. What's the name of this substance? Here's our old friend, copper again. And by now, we've got to realize, we've got to know that copper is one of those ones that has to have a Roman numeral. Well, this second thing here is the sulfate ion. So is this copper 1 or copper 2? I know sulfate's a -2. That means in this case, to have been reduced, this must have been the copper 2. Another mole problem. Disulfur trichloride. Disulfur trichloride. Well, setting up the problem, 0.0525 moles. One mole is some number of grams. Well, it's 3 chlorines is about 105. 2 sulfurs is 64. So this gets, I think, 106. Actually, it's right about 170 grams. And this was from adding up 2 sulfurs and 3 chlorines from the periodic table. What's the formula for magnesium oxide? Well, magnesium is a +2, oxygen is a -2. Cross and drop, those reduce. It's that right there. Gallium hydroxide. Gallium is Ga with a charge number of 3. Hydroxide is a polyatomic ion, -1. Cross and drop, GaOH3. Now, when drawing the Lewis dot structure for nitrogen gas, remember, nitrogen is one of those diatomic molecules. It always pairs up with itself. Nitrogen has 5 valence electrons. So 2 nitrogens can get together and share electrons to satisfy the octet rule. They share there, they share there, and they share there. Now, each nitrogen has its own lone pair of electrons. Let's count up how many electrons are being shared. Is this one being shared? Yes. Is that one? Yes. Is that one, that one, that one, and that one all being shared? Yes. So there are 6 electrons that are being shared and 4 that are not, that stay with their original nitrogen. So the answer here is 6. There's 6 electrons that are being shared between 2 nitrogens. The name of this substance, that is calcium. This is the chlorate ion. So we say calcium chlorate. What is the name of this substance? Once again, 2 nonmetals. So this is a carbon, but now we have to say dicarbon because there's 2 of them. Octahydride. Hydride for hydrogen, the octa because there's 8 of them. 0.252 moles of NaOH. 1 mole of NaOH is 40 grams of NaOH. How did I get that number? I went to the periodic table. A sodium is 23, and oxygen is 16, and hydrogen is 1. Together that adds up to 40. What is the formula for lead 2 nitride? All right, lead, Pb. Lead can be a 2 or a 4, but here I'm telling you it's the +2 lead. Nitride refers to nitrogen. Nitrogen is always a -3, so we cross it out, we get Pb3N2. If you'll notice, that isn't one of the choices. This was another one that had a typo, so this question just wasn't scored for you on the test. How many moles in 6.82 grams of water? Well, you know water is H2O. There's 18 grams of H2O in 1 mole because there's 1 oxygen is 16, and hydrogen, it being 1 each, is a total of 2. So together, the grams per mole, the molar mass of water is 18. Name of this substance, here we have silver. We have another one with polyatomic ions. We saw this one previously in the test. This is silver sulfite because SO3 is the sulfite ion. All right, so if you have any questions about how I got any of these, hopefully you paid attention, listen, and strengthen your knowledge of these concepts before you take the makeup test tomorrow. Once again, let me remind you, you must take the formative assessments. You must have taken them all in order to qualify for the makeup test.